Okay. Right, just to recap what we already know, there is a difference between distance and displacement, and those differences are that displacement being a vector. It is also defined differently. We're not used to having it defined as distance from the starting point, whereas distance is just the total distance travelled on a journey. So that's it's a scalar value, as we said from last time, and it's just totally, you add up every part of your journey. Right, so we get up to this point here now, and yes, that last time we were together, we found that the word velocity is needed and compared to speed. We do need another thing called velocity. We don't just have speed, we have speed and velocity. There is a need for velocity. We can't just say, okay, well, why do we really want it? Okay. So what is and how do we work out what velocity is? We said that it was a measure of the rate of change of displacement. So what is rate of change of displacement? So let's go back to, if I can get it to work quickly. That's it. Rate of change was a division by time. So the formulas that we're going to use, we're going to say that velocity or speed, the two formulas will be the change of displacement divided by the time taken for that displacement change. Okay? Now, if you have to write, obviously maths does not like sentences in our formulas, so we are going to rewrite that and use a mathematical symbol that you will know very, very quickly in year 11. It is going to be part of your calculus. And we put a little triangle, and the triangle is a symbol, is the capital D in Greek, and it means change in. Okay, so it's saying change in R. Okay? A capital D that's a delta. That's what the symbol is. And the other one is over the time taken for that to occur. Thank you. Speed is change in distance over change in time. So just to remind ourselves, this is change in displacement. And this one here is change in time, a change in distance. And the time taken for that thing to occur, we just have to measure that as well. So let's just do an example of both of these changes. So, going on with this. Come on, machine, go forward. Right, here is our example. We're going to start here, and here's the journey. I'll just go through it one at a time, and we'll stop there. The journey is, we're starting at home, and we go 10 south, and then 20 towards the east. What's the distance that I've travelled? 30, so we just add up the two legs. But the displacement is different. Displacement is given by that orange arrow there. The displacement is the hypotenuse. Remember, it says it's how far are you away from your starting point. So you are that length across there away from your starting point. So your distance and displacement are not going to be the same. And you could use trigonometry, but it's easier to just use Pythagoras' theorem. So whereas distance is 30, what will be the displacement? Displacement will be given by that. It's 22.4 kilometres. And we also now need to work out the angle. Now the angle, this angle in here, will be found out by tan. Are we okay with that tan? So that's the opposite over adjacent, so that's 20 over 10, which is 2, so tan theta is 2, and using the calculator is just 63 to the nearest degree. Okay. So displacement, using that and then putting it into north, east, south and west, it's south 60 degrees towards the east. So don't forget that displacement requires a distance, a direction as well. Okay, now we've got displacement, we've got distance. Let's see what time it was taken for it. So imagine it was taken in 30 minutes. So we did this trip, we drove 10 kilometres south and then 20 kilometres east, all up in 30 minutes. If you think about it, that's a kilometre a minute, isn't it? 30 kilometres, 30 minutes, a kilometre a minute. Okay? So we've automatically got the speed. Don't forget though that we could have it in kilometres per hour, metres per second. They're all different versions of speed. So if you need to, you might have to change the time from being in hours to minutes, minutes to hours, and so on. Okay. So remembering speed is just distance over time, your distance travelled, and so it's 30 kilometres for 30 minutes. Or if you want it in kilometres per hour, then it's kilometres per hour. So here you'll get kilometres per minute, because if that's kilometres and that's minute, so that's the unit of speed. Here it'll be kilometres per hour. So make sure you choose wisely. If you want metres per second, then you'll have to have the 30 kilometres here as 30,000 metres, and this would have to go into seconds. I'm going to go with that. Rightio. Now that's getting the speed. However, if we were to do, wanting to do it with displacement, however, and we do that means we're going to find velocity. Velocity is the change of displacement over time. Now I couldn't find the triangle symbol on the keyboard when I was doing the graphics, so I just put R over T. Are you okay with that? I'll just drop that in the triangle. And if we keep on going with this, have a look at the difference. It's 20, this is the displacement divided by 30, but notice what has to be also placed into our equation. Direction. Okay? Notice that this direction here can be placed at the end when we do it, and that's where we do put it. So it's 22.4. I've rounded to one decimal place. It's up to you what level of accuracy you're going to round to. So that's in kilometres per minute, and here is in kilometres per hour, the velocity. Note that they both have a direction attached to it. Okay? So, when we are doing all of this, all of these speeds and velocities, no matter what we're doing, and using this formula, the distance over time or whatever, these are always called averages, and you'll often see the little AVE down the bottom of the formula. So, if we were to stop there, why are they all average speeds, average velocities? Anyone got an idea? Okay. Well, if you were to travel from your place today to school, sometimes you would be going slow, sometimes you stop, sometimes you start, sometimes you speed up, sometimes you slow down. Why? Can you get from your place to here today without changing your speed? No. Reality is that you have traffic lights, you have pedestrian crossings, you must speed up and slow down. You did not travel at the same speed. So, when we describe it, we only describe an average version. So therefore, the formula has this little AV down the bottom, which says it's the average. So this is the velocity formula, this is the average velocity formula. Notice the same as before. So when we say velocity, in reality, I'm always meaning finding the average velocity. Okay. So don't forget it's just a displacement, and that displacement is, we don't know how we got there. It could have been a fast, slow, but over the time. That's all it is. So don't forget, sometimes you have started, sometimes you stop. Okay? Don't know why I put that slide in. For motion in a straight line in one direction, then we can say that velocity is the same as speed. So if you don't change direction, then your speed and velocity really contain the same information. Okay? But if you do go left, go right, then velocity is not the same value as speed. The average speed and velocity does not provide information about the movement at any particular point in time. Please remember, even though I said that you are travelling at 60 kilometres per hour, it doesn't mean that you're always travelling at 60 kilometres per hour. Sometimes you might have been at 65 kilometres per hour. Sometimes you're travelling at 50, sometimes you're travelling at 100. But overall, for the whole journey, you travel approximately at 60 kilometres per hour. Okay, sometimes fast, sometimes slow, but that's the average. It's an average over a period of time. And it could be 10 seconds, 2 hours, depending on what you are going to do with your time. And finally, I want to talk about instantaneous speed and velocity. The word instantaneous means at this moment in particular point in time, this instant of time. So instantaneous speed and instantaneous velocity are very hard to measure. Okay, so once again, instantaneous speed is the speed at that particular moment, and instantaneous velocity is the velocity at this particular moment in time. So how do I record instantaneous motion? Well, instantaneous motion has to have instantaneous instruments. Instruments that give you feedback at the time it is happening. So here is your dashboard of your car, and that changes its velocity or speed. The dials change as you get faster, as you get slower. That can tell you what you are doing at that moment. And when I put it here, well, it's as instantaneous as the instruments can allow. Okay, if you've got a very, if you're going up, you've got a car which has a digital speedometer. You seen those? You've got one at the back? Yeah. If you put your foot down, it doesn't do like this one here, which has a little needle and it goes zzz, up, and the needle goes from there all the way around to here. You can see it changing. Sometimes it goes, on mine, goes 2 kilometres per hour, 10, 25, 60, 80, 80, 80, 80, because I don't go past the 80. You're an animal, right? So you don't know what you are doing. It just tells you snapshots in time what it is doing. Here, you can see yourself getting faster. Okay? So digital versus, this is called an analog system where it's like a clock. You can actually see it moving and changing at the same time. Okay? They're only as good as the connection between the tyres and the dashboard allow. Okay? Are they exactly telling you exactly every second of the day what is happening? Reasonably good, but they could be about a half second later than what is actually happening. Are you understanding what I mean by that? Okay. Rightio. So that's how we work out, or the summary of all the